What's up, everybody, and welcome back to another math puzzle. In this one, the question is as follows. Find a two-digit number with the following conditions. The number is 7 more than 6 times the sum of its digit. If 18 is subtracted from the number, the digits are reversed. Hit that pause button and see if you can figure it out. When you're ready, hit play, and I'll give you the explanation. Now, of course, we could do some trial and error to figure this out, and if that's going to be your method to get this answered, no problem, more power to you, but I'm going to show you an algebraic way to approach this. So we've got a two-digit number, and the way we can represent a two-digit number, right, if we have two digits here, I can call them each digit a different variable. I'll call this one X, and I'll call this one Y. Okay, but then to represent Y as its inherent value, right? Like if this is 27, for example, X can just be 7, but Y while it's the digit 2, it actually has a value of 20. But I want to solve for it as a digit. So we're going to bear that in mind as we set up our equation. So first of all, it says the number is 7 more than 6 times the sum of the digits. So X and Y are going to represent those digits. So how do I represent the number? Well, X will be whatever, let me erase the 27. X is going to be the one spot. To get to generate this actual two-digit number, the value of it, I can't just say Y, right? X plus Y, because again, in that example where it's 2 and 7, 2 plus 7 is 9, it's not 27. But if I multiply the 10's digit by 10, I get its real value, 20, right? So now I've got X plus 10Y that represents the number. When I see the word is, that's an equal sign. 7 more than 6 times the sum of its digits. Well, now I have an equation representing this situation. The only problem is I got two variables. One equation, two variables, not solvable. But we can get a second equation, we can do this. Well, I can get a second equation right here. If 18 is subtracted from the number, so again, X plus 10Y minus 18, the digits are reversed. Meaning, if I now multiply the X by 10 and add the Y as its digit value, I'm gonna get the number, right? We're gonna get a true equation. Now we have two amazing equations. Now we can start to solve. Okay, so what I'm gonna do is I'm gonna distribute and consolidate variables. We're gonna solve it like a traditional system of equations here. So we're gonna move, I'm gonna get the X's and the Y's on the left, and I'm gonna get the number on the right. So for this bottom equation, I'm gonna subtract 10x, X minus 10x, right? We're gonna do it like this. That's gonna be negative 9x, and then 10y minus y, we're going to minus y from both sides, is going to give me 9y, and then we're going to add 18 to the other side like so. Okay, now what about this guy? We're going to do the same thing, but first we got to distribute that 6. That's going to give me 6x plus 6y, and then we're going to bring these guys to the left-hand side. If I minus 6x from x, I get negative 5x. If I minus 6y from 10y, I get 4y. And then we're going to keep that 7 over here. Now, if you guys are familiar with systems of equations, we need to get these guys matching up, either the x or the y, so we can eliminate. Let's match up the x's just for fun. So I'm going to multiply the top equation by negative 5. So I'm going to get positive 45x. And the bottom one by positive 9. So I get negative 45x. Okay, let's see if we can make some room over here. So now this top equation is going to be 45x minus 45y is equal to negative 90. Down here, now as I distribute the 9, I get negative 45x plus 36y is equal to 9 times 7 is 63. Now we're going to add these together. These guys are going to cancel out. Negative 45y plus 36y is negative 9y. Negative 90 plus 63 is negative 27. Then we're going to divide both sides by negative 9, and we get y equals 3. Well, look at that. We got one of the values. Now let's see if we can solve for x. So now I'm going to take that. I'm going to plug it into either one of these equations. Let's just plug it into the bottom one. The negative 5x plus 4y equals 7. So negative 5x plus 4 times y, which is 3, so 4 times 3 is 12, is equal to 7. We're going to minus 12 from both sides. Negative 5x is equal to 7 minus 12, which is negative 5. Divide by negative 5, and x is equal to 1. So there we have it. So what's the two-digit number? It's yx, aka 31 or 31. That's how you do it. Done. I hope you guys enjoyed this math puzzle, and if you did, please click that like button. If you want to see more math puzzles on the regular, make sure to click subscribe. Thank you guys so much for joining. See you in the next video. Take it easy.